Equipment Lesson 3 covers generators, transformers, and rectification. The wall power coming into an imaging department is alternating current at 60 Hz and 110 to 220 volts. X-ray production requires direct current at 25,000 to 150,000 volts. Getting from one to the other is the entire job of the X-ray generator. Circuit 12 minutes. 3 transformers operate in the X-ray circuit. Each one handles a different part of the voltage pathway. The step-up, or high-voltage, transformer takes the line voltage and increases it to kilovoltage levels. It has more secondary turns than primary turns. The turns ratio is greater than 1, for example, a 500 to 1 ratio steps 200 volts up to 100,000 volts. This transformer sits inside the high-voltage tank surrounded by insulating oil. The step-down, or filament, transformer does the opposite. It decreases line voltage to the low filament voltage needed to heat the cathode filament, typically 3 to 12 volts. It has more primary turns than secondary turns. It feeds directly into the cathode filament circuit and controls tube current. The autotransformer uses a single winding serving as both primary and secondary. It handles kVp selection on the console, providing a range of input voltages to the step-up transformer. It operates on incoming line voltage and allows fine adjustment of all console parameters. The transformer law, voltage ratio equals turns ratio. Increasing voltage decreases current proportionally. Power in equals power out in an ideal transformer. Look at this bar chart carefully, it shows voltage ripple percentage for every generator type, from worst to best. Voltage ripple is the percentage variation between peak voltage and the minimum voltage during the exposure cycle. A 100% ripple means voltage drops all the way to zero between pulses. A 1% ripple means it barely varies from the peak. Why does ripple matter? Higher ripple means more time at low voltage, which means more low-energy photons produced, which means more patient dose for the same image quality. Lower ripple produces a harder, more efficient beam. Single-phase full-wave rectification 100% ripple. 3-phase 6-pulse, approximately 13% ripple. 3-phase 12-pulse, approximately 3.5% ripple. High frequency, less than 1% ripple. Essentially constant potential. This is the current standard in all modern digital departments. The same kVp setting produces a harder, more efficient beam on a high-frequency generator than on a single-phase unit. This is why you cannot directly compare technique charts between different generator types. Rectification converts the alternating current from the wall into the direct current the X-ray tube requires. AC voltage alternates between positive and negative peaks 60 times per second. The X-ray tube only works on positive voltage. Electrons only flow from cathode to anode in one direction. Half-wave rectification. Diodes block the negative half of the AC cycle. Only the positive half reaches the tube. 60 pulses per second. 100% ripple. Very inefficient, not used in modern departments. Full-wave rectification. A diode bridge flips the negative half into positive pulses. 120 pulses per second. 100% ripple. Better than half-wave but still significantly less efficient than 3-phase. 3-phase 6-pulse, 3 overlapping single-phase waveforms produce 6 pulses per cycle. Approximately 13% ripple. Much more constant potential. Higher average kVp for the same peak setting. 3-phase 12 pulse, 12 pulses per cycle. Approximately 3.5% ripple. Near constant potential. Very efficient. High frequency. The high-frequency generator deserves its own attention because it is the equipment you will work with throughout your career. It converts standard 60 Hz wall AC to high-frequency AC, anywhere from 500 to 25,000 Hz, using solid-state inverter circuits. That high-frequency AC is then rectified and smoothed into near-constant DC. Voltage ripple is less than 1%, essentially constant potential output. Advantages: compact size that works on single-phase wall. Power: no 3-phase electrical installation required. Precise kVp and MAS control with millisecond timer. Accuracy: highly reproducible exposures with minimal variation between identical technique settings. And the lowest patient dose for equivalent image quality of any generator type. 4 timer types govern exposure termination. The electronic timer terminates at a preset time, accurate to milliseconds. The MAS timer terminates when a preset MAS value is reached, more accurate than time-based termination alone. The synchronous timer was based on 60 Hz AC cycles. Obsolete and no longer used. And the backup timer is the safety cutoff that fires if the AEC fails to terminate an exposure. This chart shows the QC concept for kVp accuracy, comparing set values to measured values across the kVp range. In a properly calibrated system, the measured kVp should track very close to the set value at every station. Deviations greater than plus or minus 4 kVp require calibration. 5 generator QC tests. kVp accuracy, measured kVp. Within plus or minus 4 kVp of indicated value. Timer accuracy, within plus or minus 5% of set time. MA linearity, output within plus or minus 10%. Between MA stations. Reproducibility, coefficient of variation 0.05 or less across repeated exposures at identical settings. An HVL measurement confirms adequate filtration for the operating kVp. Line voltage compensation is handled by the autotransformer, which automatically adjusts for fluctuations in the incoming wall voltage. Without line voltage compensation, kVp would vary with every fluctuation in the building's electrical supply. 3 generator questions in the registry format. The answer is D, high-frequency generator. High-frequency generators convert 60 Hz wall AC to high-frequency AC. Rectify and smooth it to near constant DC. Voltage ripple is less than 1%. This produces the most efficient, reproducible, and dose-effective beam of any generator type, and is the standard in every modern digital radiography and fluoroscopy system. The answer is C, the step-up, or high-voltage, transformer. The step-up transformer has more secondary turns than primary turns. Its turns ratio steps line voltage up to the kilovoltage levels needed for X-ray production. The autotransformer handles kVp selection, but doesn't produce high voltage. The filament transformer steps voltage down to heat the cathode filament. The answer is C, a malfunction in the AEC system requiring investigation. The backup timer is a safety device designed to terminate an exposure only if the AEC system fails. It should never fire during normal clinical operation. Activation. Indicates an AEC malfunction. The equipment must be taken out of service and serviced before further use. You covered all three transformers, the voltage ripple chart. Comparing all generator types, every rectification method from half-wave through high-frequency, power timer types, and generator quality. Control. Generators are the power plant of the imaging system.